2008, the research group ASTRA of the University of Antwerp in Belgium presented their groundbreaking desktop supercomputer, the FASTRA. Powered by 8 GPUs, the system was, at that time, among the most powerful single PCs in the world, beating even a large-scale supercomputer. The group uses this machine for their computational research on tomography, a technique for three-dimensional imaging. X-rays are recorded while rotating around a patient and subsequently converted into a three-dimensional image by a complex mathematical procedure that requires massive computation power. FASTRA's powerful design is based on GPU computing, the use of 3D gaming hardware for general computations. It attracted attention from general media and technology press worldwide, as well as substantial interest in the scientific community. The YouTube video presenting this project was viewed almost 200,000 times, giving rise to discussions all over the World Wide Web about the new technology or just about the presenter of the movie. Today, the ASTRA Group is back with a brand new supercomputing project. The goal? Pushing desktop supercomputing to its outer limits.
Hi, my name is Joost Batenburg and I'm a researcher at the Vision Lab of the University of Antwerp in Belgium. Since the introduction of our FASTRA desktop supercomputer last year, the system has provided us with massive computational power. Of course, being computer geeks and all, we like to show off our system to the world, but it is also a big necessity to just perform our daily research. Consider, for example, our work on the three-dimensional reconstruction of bone. Bones are currently tracked during medicine research for osteoporosis, for example, several times. Typically this is done by X-ray microtomography, what you can see there. Well, with the first edition of FASTRA, we are already capable of reconstructing large three-dimensional bone datasets in a very short time. The problem is to really get the full resolution that you need to see the small microstructures in the bone, you have to go very close to current scanner resolution limits. We have recently developed new techniques that are capable of going beyond this resolution and upsampling the reconstructed volume. These techniques are very powerful, but they require even more computational time. To get double the resolution in all 3 dimensions, you need 8 times the computation power. And even FASTRA I cannot deliver this. The bottom line of this, we need still much more computational power crammed inside a single PC. Here you see our latest design, the FASTRA II. Compared to the FASTRA I, which had 4 graphics cards, the new design now has 7 graphics cards for a total of 13 GPUs. It packs an astonishing 12 teraflops, which is comparable to a modern supercomputer costing millions of euros. To build a system that is even much more powerful than the first edition of FASTRA, we had to overcome several physical obstacles. The first one concerns the motherboard. At the time we built FASTRA I, the biggest motherboard available had 4 PCI Express slots. Now, about a year ago, Asus came with their new motherboard product line, where you can see this motherboard that has 6 PCI Express slots, and there even is a version with 7 such slots that we used in the design of FASTRA II. Now, having many slots available is one thing, but the latest gaming cards are very thick and they don't fit all simultaneously in the 7 slots. To deal with that, we came up with these flexible PCI Express cables that go into the slots and allow you to suspend the cards over the motherboard, so they don't have to fit all together. However, the mass required for such a big block of graphics cards is enormous, and so we had a custom cage developed in collaboration with a Belgian computer company called Tones and a laser cutting company that allows you to suspend all the cards over the motherboard. Now, a final concern that was already some issue with FASTRA I is heat. With 2 FASTRAs in a room, additional heating in the winter is no longer necessary. When starting this project, we hoped that just assembling all the hardware would lead to success. Excited and all, we turned on the system for the first time. And nothing happened. Now, the problem with this system is that the motherboard uses a 32-bit BIOS, and this cannot deal with all the graphics cards simultaneously. Now we collaborated with ASUS, and they came up with a special custom BIOS that allows us to boot with all these cards. But it still requires hacking, stuff like modifying Linux kernels to get it actually working. Although our new FASTRA II system is not as general as a traditional supercomputing facility, it has many advantages. First of all, it is very green, taking a fraction of the power required to power a large supercomputing facility. Second, it is also highly mobile. You can take the system under your arm and take it just anywhere. And finally, it is also very inexpensive. Costing less than 6,000 euros, you get a supercomputer that is as powerful as a whole facility costing millions of euros. Now we are currently still working on this system as we are encountering some problems in getting it stable. So if you want to know more about the status of our work, check out the website.